Hey guys, we're going to be continuing Chapter 8, Section 2 here with multiplying and factoring. So you're going to learn how to multiply a monomial by a polynomial and then how to factor a monomial from a polynomial. So let's go ahead and jump in here. No vocab with this one, which is nice. To multiply a monomial and a trinomial, if you're multiplying anything by a monomial, so here's my monomial, think of it as the distributive property. I mean, that's the easiest way to come about this. So this whole thing right here is going to equal negative x cubed times all of these different things. Here it's negative x cubed times, make sure that this minus goes with the 2, so negative 2x cubed, and then negative x cubed times 7. And for each one of these, I just multiply them. So here I have negative times 9 is going to be negative 9. Same basis, so I add the exponents, so negative 9x to the 7th. Here it's a negative times a negative, which gives me positive. Keep the 2, and then 3 and 3 get added. So this is knowing the exponent rules from our last unit. Here it's negative 1 times 7 is negative 7, and then just the x cubed. So that is all you're doing on this is going to be distribute that monomial to everything in there. That should not be too bad for you. Here's another one. Yeah, go ahead and you try. The answer will be up in 3, 2, 1. All right, so here's what I got. Go ahead and check what you have with this. If it's different, then try to find your mistake. Let's keep moving. All right, here is how I feel after daylight savings. Daylight savings is near. I don't like morning people or mornings or people. I love Grumpy Cat. He's my favorite. All right, so finding the greatest common factor says what is the GCF of the terms of 5x cubed plus 25x squared plus 45x? If you recall when you were first learning about greatest common factors, let's say, for instance, we're going to find the GCF of 27 and 36. Remember, you find the greatest common factor when you simplify fractions. So here, if I were going to find the greatest common factor of these two things, there's a couple ways you could do this. You could just think, well, what are the numbers that I could divide out of both of those? What's the largest one that divides out evenly? That's one way to do it. But another way to think about this is to consider its prime factorization. So this is 3 cubed. And then this would be, we could do 4 and 9, and then 2 and 2, and 3 and 3. So 36 is 2 squared times 3 squared. So here's the prime factorization of 27. Here's the prime factorization of 36. What I'm looking for is the prime factors that they both have. So 27 has no 2's in it. 36 has 2 2's. That's what this means. This has 3 2's. So what is the greatest number of factors that they both have? Well, they both have 2 3's. Okay, which 2 3's is equal to 9. The greatest common factor between 27 and 36 is 9 because this is the largest exponent that they both have. All right, so if this has 3 3's and this has 2 3's, then what's common among them? Well, 2 3's. So that's the way I want you to think about these right here. Erase all this. So the best way to find these GCFs of these polynomials is to write these out in expanded form. So we're going to go ahead and do that. So for expanded form, I need to think about the prime factorization. So 5 is a prime number, so that's already there. So I'll do 5 times x times x times x. 25 is the same thing for prime factors as 5 times 5 times x times x. 45 is going to be 3 times 3 times 5 times x. And then what I do is I look in here, what are the factors that they all have? Well, they all have a 5. So every single one of them has a 5. And then they all have 1x. So what they all have is going to be my greatest common factor. So for this one, they all have a 5 and they all have an x. If I had more than one number that came out, I would need to go ahead and multiply those. But for this one, it's just the 1, so it's 5x. Again, write it out in expanded form using the prime factorization, expand the variables, and find what they all have. So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's what I got. I got 3x. I do want to point something out. Anytime you have a negative, you need to include -1 as part of the factors here, because if they all have a -1, then you could factor that out as well. So just make note of that. Let's keep moving. Factoring out a monomial. So the first slide that we did was using the distributive property to multiply by a monomial. But what if I want to pull the monomial out? How am I going to do that? Well, the first thing is do what we just did. I need to figure out what is the greatest common factor between these three different monomials. So 4 is the same as 2 times 2 times x times x. A lot of x's here. All my x's live in Texas. It's not true. They're all in Kentucky. Here I got 2 times 2 times 2 times 3. If you can't find the prime factorization in your head, then write out the factor tree. That will make that a little bit easier for you. Let me just double check this. 2 times 2 is 4, times 2 is 8, times 3 is 24. Good, we're good on that. Here I have 2 times 2 times 2 times x. And I go through and I find what do they all have. Well, here's a 2 and a 2 and a 2. Here's a 2, and a 2. Those 2s, those 3s aren't going to be useful. Here's an x and here's an x. So the prime factorization is going to be 2 times 2 times x, which is the same thing as 4x. So when I factor out the monomial, this value right here, the greatest common factor, is going to go in the front of some parentheses. And then I'm going to rewrite all of these different monomials with just what's left over. So here I have x times x times x times x, which is just x to the 4th. This I have -1 times 2 times 3 is -6. And then I have 3 x's. And then here the only thing that's left is that +2, so I'll write +2. So here is my factored out version where I factored out a 4x by finding the GCF of all of these as well as the variables. Okay, so find the GCF, write that in front of the parentheses, and then whatever's left is what goes inside the parentheses. Here's one for you to try. Go ahead, and the answer will be up in 3, 2, 1. All right, so here is what I got and how I got it. So check your work against that. If you made a mistake, go back and try to find it. Let's keep moving. All right, word problem. It says a helicopter landing pad or a helipad is sometimes marked with a circle inside a square so that it is visible from the air. What is the area of the shaded region of the helipad at the right? Write your answer in factored form. All right, so the first thing I need to consider is that I have this area of a square, and I know how to find the area of a square, which is just the side squared. And then I also have an area of a circle here, which is going to be pi r squared. And I have some values in for this. To find the area of the shaded region, I'll find the area of the circle, and then I'm going to subtract that from the area of the square. So let's go ahead and substitute some things in. The side length of my square here is going to be 2x. So I have 2x squared. Here the radius is x. So for this I'm going to have pi, and then x squared. And these things I could simplify some stuff out here. So 2x squared is going to be, remember that, it's not distributive property, but it's similar. It's going to be 4x squared. And then this down here is just pi x squared. So here is the area of the square. This is the area of the circle. So I want to write this. This is going to be called writing this in terms of pi. In other words, I want to leave the symbol pi because it's an exact number. I don't want to estimate it using a decimal. So here, from here, I'm going to go ahead and write these out in those long ways that I know. So 2 times 2 times x times x. This is pi times x times x. So what do they all have in common? Well, I have an x and an x and an x and an x. So we'll get to this in just a second. So in order to find this, I'm going to have 4x squared minus pi x squared. And I needed a -1 right here. So there's my -1. So I'm going to factor this out. And what I'm going to take from each one of these is this x squared. So the x squared goes in the front. And then what am I left with? Well, with each one of these, here's my parentheses. So I'm left with 2 times 2 for that first one, which is 4. And then the second one, I'm left with -1 times pi, which is just -pi. So x squared times 4 minus pi is the factored version of that. And this is called writing it in terms of pi. In other words, I leave the pi sign in there. You will have problems like that. So make sure that you are really taking good notes on this. Start with the areas that you know, and then subtract them by plugging things in, and then factor out what you need to. I believe that's it. Yep, that's it for today's notes. So hopefully you took good notes. I will see you all in class.